Let's look at solving a couple of others. Okay, the first type of logarithm was the type that could be expressed in this format. The log of a single quantity equal to a constant. We went ahead and converted it and was able to solve that logarithm equation. Your equations may also come in this format, where you have logs on the left and logs on the right, where you have logarithms on both sides. If we can express it as a log of a single quantity on the left and the log of a single quantity on the right, then we can we have this equation set up, and since the bases match and it's a log and a log, they kind of cancel each other out. All we have to solve for is m equal to n. Sort of like the first exponentials we did when the bases matched. So I noticed logs on both sides of this first one, so I'm going to try and gather them together so I can have a single log on the left and a single log on the right. So always look in your equations to see if you can combine logarithms. And since these are added, we can combine them with multiplication, x times x plus 1. And on the right, it's just log 5 of 20. If I can get my logarithm equation in that format, then all I have to do is cancel out my logarithms and solve the resulting x times x plus 1 equal 20 equation. Only if I have logs on both sides. We see another quadratic come in. X squared plus x minus 20 equals 0. I guarantee that these will all factor for you. If you can't get it to factor, then you made a mistake somewhere above. X 4 times 5, negative 4, positive 5. And if we set them to 0, we get 4 and we get negative 5. Remember, we have to check our solutions. If I put a 4 in the original, I'm taking the log of a positive number, we're good. If I put a negative 5 in the original, I have a problem because I end up taking the log of a negative number. Throw that one out. So one answer, x equal 4. Over here, one answer, x equal 5. Let's look at this last one. Let's take these two logarithms, combine them, and work it from there. ln x minus 3 equal ln, and since that's a subtraction, we're going to divide them. 7x minus 23 divided by x plus 1. We're combining that into a single logarithm. They're subtracted, they get divided. Since it's a format where I have a log equal to a log, I can cancel the logs and solve the resulting equation. X minus 3 equals 7x minus 23 over x plus 1. Now this is going to test our algebra skills. It's been a while since we've solved an equation like this. If you recall, to get rid of the x plus 1 in the denominator, we're going to need to multiply both sides by x plus 1. That's going to cancel out the x plus 1's, and on the left-hand side, we'll need to multiply that out to get an x squared minus 3x plus x minus 3, and that's equal to 7x minus 23. I just use the FOIL method to multiply that out. X times x times negative 3, 1 times x, 1 times negative 3. Quadratic again, so let's get everything on one side, get it equal to 0. X squared, if I bring the 7x over and subtract it, I'll end up with a negative 7x, a negative 3x, and a positive x, so that'll be a negative 9x. If I bring the 23 over, it's negative, so I'll add it. I end up with 20. this should factor. X and X, 4 times 5, negative 4 and negative 5 add up to negative 9, and they multiply to positive 20. So two solutions here, 4 and 5. I'll put a 4 in place for X. I'm okay, it checks out. Put a 5 in place for X. I'm good. Got to check it back into the original problem to see if they work out where you don't end up with the log of a negative number. And we don't end up with the log of a negative number for that. So that's how we go about solving our logarithm equations. And finally, one last thing here is an application. Medical research indicates that the risk of having a car accident increases exponentially as the concentration of alcohol in the blood increases. Okay, we all know that, but some mathematician came up with the model. So the mathematician's job is to look at the data, come up with an equation, and then we can use that equation to determine risks in other categories. And in this case, determining the risk of having a car accident. But there's a mathematician somewhere who came up with this model. R is the risk. What is X? X is the blood alcohol concentration. R is the risk. So what we want to do is figure out what blood alcohol concentration. We want to find the blood alcohol concentration. We want to find X when we know there's a risk of 20%. Make sure you put the 20% in the right place. It's going to go in place of R. So 20% is equal to 6e to the 12.77x. X is what we're trying to find, the blood alcohol concentration. It ends up being an exponential equation that we saw earlier. How to solve that? We have to isolate the exponent term. And I'll isolate that by dividing both sides by 6. I'll just leave it as 20 divided by 6 right now. Now, to undo this exponent, it's in the form where we're going to have to take the log of both sides, and we'll choose ln. Just works out nice because the understood base is e, and that stuff cancels. ln of 20 divided by 6 is going to be equal to 12.77x. One last operation. Let's divide by 12.77. We're going to go to our calculator for this and figure out the value of x by calculating this. ln 20 divided by 6 divided by 12.77. ln 20, oops, I didn't want to do that. ln 20 divided by 6, and that whole quantity divided by 12.77. 0.09. So if your blood alcohol concentration level is 0.09, then you are at a 20% risk of having a car accident. And you can kind of play this game for different levels, for different risks, or for different blood alcohol concentration levels. The next part I have on here, but we're not going to worry about because this isn't a part that is in the exercises. So we'll just forget about these two and call this section done. Look at the applications, look at the technology problems in the book, and check out the assignment on Course Compass. And that's it for 4.4.